Hey guys, welcome to another stream of the illus2D engine series. I'm back after a while. I'm back after doing some stuff that I had to do, and now I'm back. Yep. So this is gonna be a chill stream. I'm just gonna play on some music probably. Yeah, I hope you guys can hear the music. Yeah, I'm just gonna play some music, and we're just gonna be like maintaining our code because I realized that because I was just skimming through the code the other day. And I realized there are some things that are left to maintain. Okay, so yeah, we're just gonna be getting hang of that right now. All right, cool. Let's just get into it. I hope my streaming is going well. Yep, stream's going okay. Stream's going okay. All right. Let's start maintaining. I have a little list of what I have a list that I have planned. I have written the list in my notebook here, and I'll just go from top to bottom. Okay. So if we take a look, let me go to the oh my god, there's so much stuff open from last episode. Get rid of all of this. Damn, it looks like everything is open. What the hell? And by the way, today is so hot outside, so I have like I have a big bottle of cold water. It's extremely cold. Like if you guys can hear or not, I'm not sure, but there's still ice in here. There's like big chunks of ice. So yeah, I'm probably. Oh man, it's so cold. So if you guys just don't mind me, okay? I'll be sipping a lot of water in this stream because it's just so hot outside where I live. Okay. Cool. Okay, so the first thing that I want to change about kind of maintain is this this thing right here. So if we take a look, go to utilities. If you take this util class, to be honest, we named it util, but to be honest, it's just a clock class. Okay, it's just gonna calculate our time, our delta time and stuff. So I think it makes more sense if we just call it like clock, right? And yeah, that's what we're gonna do. We're gonna be naming it clock. I'll rename this to clock.h. This to clock.cpp, and it's gonna give us a bunch of errors because we have to do stuff. And wow, clock.h. Okay, clock.cpp. Okay, let's just change it. Let's change it. I'll probably just do a find and replace. I guess it makes more sense. Replace. I'll find util. With capital U, of course, and replace that with clock. Current document, replace all. 7 occurrences replaced. Cool. All right. Of course, we're gonna get a bunch of errors here. Except last time is undefined. This is undefined. This is undefined. Of course, because we have this still in the util, we're gonna change that to clock. Let's go back here. We should be. Yeah, we got rid of some of the errors. Counter, of course, we're gonna change that. Identifier counter is undefined. Clock.h. Yep. Include clock.h. I'll okay. Our yeah, when we did like a find and replace, it changed our namespace name as well. So yeah, let's get back to util. Everything works fine. All right, so now I want to refactor this class a bit. Okay, I don't want these functions right here. I'm just gonna make like a variable. I'll call it something like and also we didn't take use of our convention. So let me just put p underscore right here, and let me add a function. I'll call it float p underscore delta time. We had this counter. I'll just get rid of that. Last time, of course, we can copy that, and we'll have another call int p fps. Okay, we'll have these. Get delta time. Of course, we can just make an inline function of this. So inline get delta time. We can just return p underscore delta. Okay, cool. I'll put this behind. And here is I'll get rid of this. I'll do a void process in process. Wait, what do you name that? I guess we named this one poll events. Okay, so yeah, we can call it process inputs. Process inputs. Okay, cool. Let's get back to here. I'll literally just get rid of this. Bam. These, of course. We'll do p underscore delta time 0. Last time 0. Frames per second 0. And last time, okay, this should be here. I like to make it in order, like the way I define it. So yeah, this, then this, and this. Okay, cool. I hope we're streaming. Yes, we're streaming. Awesome, awesome. Last time, of course, it's gonna be p underscore last time. Now I'll rename it something like I'll rename this function to process inputs, and now I can just last time crying time to the goes this delta time. Of course, I have to just do p delta time, and I'm not gonna return anything. And also, this is gonna be a void function. Okay, cool. That's pretty much it. Clock.h, we keep it till last time. Oh, fine. Let's get the FPS now. So p underscore FPS, we'll just put the FPS here as well. Why not? So p FPS is casted to an int, just a normal cast. 1 over we'll do p underscore p underscore delta time. Right, and we'll do here, we'll copy this, paste it here, int get FPS, return p FPS. Alright, cool. That's good. Yeah, that's basically our clock class. It's completed. It has delta time and FPS. That's pretty much all we need. We don't need anything else. We can do something like start timer. Yeah, exactly. We can make like a start timer stuff and like calculate time, how much time it took for us to do this or stuff like that. But for now, we're not going to be doing it, because the main reason why people will start timers is to calculate delta time and FPS, and since we've already done it in the delta time and FPS, I guess I don't think it makes really even any sense at all. So yeah, this is pretty much it. This is our little clock class. I will get to the engine.h. I will rename it to clock.h. That should be enough. And here, main.cpp, I can probably do something like I'll of course make a class of the clock. So using namespace util, make a clock class, clock. It takes in nothing, of course. And we'll do clock.process inputs, and we can just do something like cout clock.get frames per second. That should work. Let's just rebuild the whole solution. And in the meantime, I was gonna have my water, of course. Like, it's so hot here, guys, so hot. There we go, build succeeded. I want to get the music up a bit. Fine. Run the code, and we see our FPS here. Cool. That's good. I'm just gonna get rid of this. We'll keep the process inputs here because it will update the delta time and FPS every single frame, and that's exactly what we want. So we'll just keep the clock to process inputs right here. We're not gonna touch it. I'll make a little thing called draw. The music is a bit too loud. I think I'm not sure. I'll just yep. Okay. This is the sweet spot for music and programming. I just love it. All right. That's pretty much it. So we have our clock class. After this, I wanna let me see what we have. Oh yeah, I remember in the window class we didn't use our convention. We did something like dash window or something like that. I'll just do something. I'll just add p in here. I could like do a find and replace, but the thing is that we use underscore here as well, so we can't really do that. So I'll just do p underscore. I'll just add p everywhere. Might take some time, but you gotta do what you gotta do, right? Let me just press the window. I guess we don't think p window here. Okay, saying YouTube is not receiving enough video to maintain smooth streaming. Hope that's not an issue. All right. Width, p width, p height, p title, p everywhere. Just p everywhere. Oh God. P. Yeah, all right. Awesome. Frame buffer callback with height. Okay. Yeah, it's good. It's good for. I don't want to change anything. Really. Just a maintenance episode. I don't want to like write absolute code. All right. So that's basically our window class. I don't think there's anything else left to do. Oh yeah. Also, I wanted to like add a function for it. For example, I want to like enable and disable. If we want to do like enable and disable the vsync, we should be able to do it from the window class because it makes more sense. So I'll probably do here. I'll probably have something like void set vsync enabled. That makes that's a good function name. And I'll just it's just going to be a const function. I'll put the definition of the function right here. Just under this, I guess, void window. So set vertical sync enabled, const, and we can just do glfw swap interval. So this is a built-in glfw function. So if you pass in like 1, it's gonna enable the vertical sync, and it's gonna match the FPS with it, like your monitor, the monitor's refresh rate. And 0, it disables it, so you get as many FPS as your computer can output. Okay, so 1. Of course, we need a way to change this. So what I'll do, I'll probably put something like bool something like bool status. I'll put the status in here. Okay, and I'll have to go here. I'll do bool status. Awesome. Make the function and it goes here. All right, that should work. Like if we wanna check, of course we can check if you want to. Let me just build this engine first, so we get the DLL in the correct space. Okay, build succeeded. So we can do something like clocked get FPS. So before we enable the vertical sync, what was happening was we're getting we're getting large FPS numbers. But after we enable vertical sync, or we can do something like here, window.set vertical sync enabled true. Yeah, see, we're getting like 59, 60, 61 FPS. So it's so we're basically capping our FPS to 60, or the refresh rate of our monitor. See, 60 stuff. Yeah, cool. That's good. That's good. I'll probably set it enabled, I guess, for now. You know what? I'll just disable it. I'll not enable it right now. Apex. Yep. We're probably gonna use the delta time and stuff, but we're not gonna enable vertical sync stuff. Okay. Cool. Draw. That's pretty much it. That's pretty much our window class sorted out. Also, I wanted a way to get OpenGL, like a way to like see if we are getting OpenGL errors or not. Okay. There's a way. There's actually a pretty hackish way to get OpenGL errors. I'll implement one, a simple one, somewhere in the poll events. Well, something like temporary. Okay, so I'm calling it temporary because in the later streams I'm gonna make a much better. I'm gonna make like a much. I'll make a much better OpenGL error checking kind of API macro stuff. But for now, what we can do is there's actually a built-in OpenGL function called GL get error. So we can do something like unsigned int error, call it GL get error, and if I believe it's GL get error is not equal to GL I think it's GL no error. Yeah, if it's not equal to GL no error, which means that there was some OpenGL error, we'll just print in the code of the error. So stdc out, do error, so something like OpenGL error. Okay, OpenGL error, and I'll print in the code like this. So this error. Okay, this is like a hacky way to get some OpenGL errors, but in the coming streams we'll probably make a better version of this. So for now it's okay. For now it gets the job done and I like it. Alright, so that's pretty much it. That's our window class as well. After this I will do something with the hold on, let me see if there's textures. Yep, our textures are okay. Texture.cpp. Yeah, we are. Oh yeah, right. Yeah, so we are. So after we send the data to our texture buffer, we unbind the texture, and that's is a good programming practice if you're using OpenGL. So what I will do is I'll go to my buffers, and I'll literally like so let me start with the vertex buffer. So after we send the data to our buffer, what I'll do is I'll just unbind the buffer because it's just it will help us debug and stuff, and it's a much better programming practice to do so. Okay, so we'll just unbind the buffers after we send the data. Okay, I'll do with vertex array data as well. Of course, you don't have to do anything here. I'll have to do with there are ants everywhere as well. Oh damn. Ants, the damn ants, I hate them so much. Okay, vertex buffer, bind the buffer. After we send the data, we bind this no buffer to the element array buffer binding point, and we're done. Vertex array cpp. Of course, we don't have to do anything here because we don't bind it in the first place. That's pretty much it. We have vertex and index buffers, and we unbound them after we send the data. Okay, cool. Cool. Oh my god, it's getting really hot here. Holy hell. Where's my oh damn. Okay, another thing I wanna do here, vertex array. Yeah, so they have this layout stuff. The problem with this really is that we have to like make a new class. Like every time we want to set up like a vertex buffer layout, we have to make a new instance of this vertex buffer layout class. I mean, it's probably okay if you are using like a single vertex array and a single buffer. So if you're using a single vertex array and a single buffer system, it's okay. It's what you should be doing. But if you're using some other systems, like if you're using like a single vertex array, then you're using multiple buffers with that. Using this actually is kind of like it can result into a lot of problems. Personally, I have experienced a lot of problems due to bad vertex buffer layouts, like incorrect vertex buffer layout, because of having like a single instance of the vertex buffer. So what I'll do is I'll probably make a function here here in something like it's going to be a static, so that we don't even have to like make an instance of this vertex buffer layout every single time. It's going to be a void. I'll call it something like set layout, set data layout manually. Okay, kind of a long function, but kind of explains it us also what we're doing. So I guess so for me it's for me it's okay. So set data layout manually. I will do here in the last. So void VB layout set data layout manually. Alright, what does it say? Class has no members, set data layout manually. Really? Are you sure about that? Are you sure about that? Okay, so here basically what I'm going to do is for us to send the buffer layout, all we need is we need the index, we need the size, and the type is basically going to be GL float. Normalized, of course, tried and stuff like those. For now, what we'll do is this is for like I'll just make a comment for single vertex array and multiple vertex buffer systems. Okay. Rendering system. Okay. So for these, we're just gonna do this. So for example, for every vertex attribute, if there's like a separate vertex buffer, so for index number 0, we're pulling data from separate vertex buffer. For index number 1, we are pointing to separate a different vertex buffer. For index number 2, different vertex buffer. For that, we're just going to be doing these. Okay, so of course, we'll need something. Here we'll need the unsigned int, the index of the buffer, the index of the vertex array. We'll need unsigned in size, so it's the size there. We'll need the data type is also float, but I'll just pass in it here anyway. So data type. After this, we'll just need like what we're sending, like what data, but since it's going to be float for the most part, so I guess it's not a big problem. Okay. All right, let me copy this. Go down here, paste it. I'll do GL enable vertex attrib array. Enable the index GL vertex attrib pointer. So we're gonna make the vertex array the attribute list to point to a vertex buffer, and set the layout. So the layout is gonna be index, the size, the data size, type. Of course, gonna be data type. Normalized GL false. Stride is since we're using single buffers, since we're using a single buffer for every single attribute, the stride is basically going to be like the size of the data. So it's going to be size. It's going to be size of a float times the data size. So it's pretty okay. Pointer to the data. So like I said, like I said, we're using multiple buffers, so it's going to be okay. Okay. Cool. Set it out manually. So if we try to check something here, we're going to go to main.cpp. We can do VB layout, and we have the set it out manually function here. Okay, we'll kind of check it. We'll check it right now. All right. Cool. That's our manual vertex buffer layout kind of system here. Let's just check it. Let's check it. I hope this works. So we have to check it, right? Let me build this first. Build and run, so that we don't get any errors. Cool. So we have this blank window. Everything's going well. Alright, so what we'll do is we'll just make a simple buffer. So we'll do float vertices. I'm just gonna have something like 3. Yeah, we'll just make a triangle for now, just for checking. 3 vertices. We're gonna have one vertex in up there, another vertex we're gonna have down there, have another vertex down there. Okay, just a simple triangle. 3. I put another vertex in here, should be 6. Cool. I don't really need to specify the data. What am I doing? Alright, let's get the buffers down. We'll have to do let's make an index buffer as well. So unsigned short indices 0, 1, 2. It's pretty simple. Let's make the buffer. So vertex, let's make a vertex array first. Vertex array VA, short for VA. I'll make a vertex buffer. Vertex buffer. It's going to take in some data from data size of the vertices, and copy them for vertices. Okay. We're not gonna bind anything, like the whole reason why we here we unbind the vertex buffer is that when we create a vertex buffer, oh my god, where's the main look at all these files opening. Holy hell, it's a pain in the head, man. We get rid of all of these are okay. So the reason why we unbind the buffers every single time after we send the data in the constructor is, for example, if we made like a new object, like previously, if we had made like a new vertex buffer object, what was happening is it was getting bound to the respective binding point automatically, and I don't want that. I want full control over my vertex buffers, if you know what I mean. So yeah, so now if you want to bind it, we'll have to do manually. So vb.bind. Okay, that's how we're gonna roll. All right. So, but before we bind the vertex buffers, I mean, we can do it after we bind. It's not an issue, but for a good convention, for a good programming convention, what I like to do is I like to do after I set up my vertex arrays, I like to bind the vertex array, and then I like to bind the buffer. So vb.bind. So let's bind the buffer. Now we can just do vb layout dot set data layout manually. Index 1, size is 2, geo float, and that's just much better. We don't have to keep on making the vertex buffer layout class. And again, it's not for we're not gonna be doing it every single time. We're doing it again if you're using one vertex array, multiple buffers, and stuff like this. And it also, of course, works when you have one vertex array, one buffer, but a single attribute, because of course we don't have anything like stride and offset and stuff like this. Okay, cool. So we send the vertex array. So now the vertex array contains this layout, and it points to this buffer. So that's good. Now we can just unbind the vertex array, and after we unbind the vertex array, we can unbind the buffer as well. So geo vb unbind. Okay, cool. Unbind everything. Let me go to draw function. I want to draw like geo draw L. Of course we've got to do the index buffer. So index buffer IB, size of indices. Here we'll just bind the indices as well, because the vertex buffer points to the indices as well. So if we do this, we'll do ib.unbind. Awesome. We go to draw. geo draw elements, geo triangles, oops, geo triangles count. We wanna draw 3 indices. Type is gonna be short, indices pointer. We don't need to support any pointers because we have already we don't need to send any. This is like this thing right here. I used to get so much confused like when I started to learn OpenGL. Like it says indices. Am I supposed to pass my indices in here? But this is but then I later knew that it's because in previous version of like previous OpenGL, and like the immediate mode of OpenGL, there was no such thing as buffers, and there were no such thing as buffers and shaders and stuff. Okay, so in those time we used to apparently we used to directly supply the pointer to the actual buffer in here. So I might be wrong. That's what I heard in like a Reddit post sometime. Yeah, that's pretty much it. If we don't have shaders, do we? You know what? Since we actually we do have shaders. It looks like we do have shaders. It looks like they're using a vertex array to pull the data. Yeah, I guess we can just set up a shader here as well. Let's do that. Shaders. Oops, shader. Vertex shader path source. Shaders. Vertex shader GLSL. Oh my god, it's so hot right now. Like if you guys don't know, I live in Nepal, and in Nepal it's so hot. I'm moving to Canada soon, by the way. So yeah, it's gonna be quite the difference from like literally like 40 degrees Celsius in Nepal to like negative 40 degrees Celsius in Canada. Holy hell. It's gonna be fun. Dot shader.glsl. Yeah, I'm moving to Canada soon in like a couple of months for study. I'm studying computer science, information technology, IT, so I'm moving to Canada for my bachelor's. Alright, shader, take shader.glsl, fragment.glsl. Let's just okay, so here before we draw, we'll vertex array.bind, shader.bind. Run the code. Hopefully it works. Of course it should work. Yeah, of course it works. Okay, lovely little triangle. It works. Everything works. Our vertex buffer layout things work. So that's why the main reason why we wrote all this code is just to test if it works or not. Okay, so it works. Awesome. Actually, I was thinking of setting up like a projection matrix, but I'm probably not going to be setting a projection matrix right now yet. The reason is that I'm pretty sure the next stream after this is gonna be about input handling So after I have done the input handling, I'm probably going to be getting into cameras and making like an orthographic camera, so I can move in our scene and like I can zoom in and zoom out and do all those great stuff. Yeah, so basically what I think is, oh my god, it's so hard to talk when it's hot, guys. Okay, basically what I'm thinking is that I'm probably going to be setting up the projection matrices and all those matrices after I make the camera class. Okay. Yeah, that's pretty much. All right. So I guess that was pretty much it. We set up like the buffers. We unbound the buffers every single time we did it. And I believe, hold on a minute. Do we use shaders? Okay, so we don't use the parameters. Awesome, cool. We unbound the texture as well. So we send the texture when we send the texture. Yep. Works well. In the window class, we set up that. Yeah, it looks fine. It looks fine to me. Frame buffer size callback. Actually, like if I wanted to increase like my performance, I mean, let's check this as well. Let's check our error handling. What I'll do is I'll just get rid of these. Instead of writing GL unsigned short, I'll write short. Okay. And let's check our error handling. Okay. Okay, we don't get there. Let's see. GL short. Oops, I didn't mean to go there. Window.cpp, poll events, temporary, GeoGetter. Yeah, let me build solution again. Okay, we don't see the error handling for some reason. The reason is because I think of course I gotta rebuild the solution. Rebuild solution. Let me get back to my lovely bottle of cold water, ice cold water. Yeah, so yeah, right. So open GL error 1280. Okay, so we do get error. So 1280 is a GL unsigned enum. If you gotta know like what these codes mean, you can search like there's like an OpenGL documentation website where it shows all the error codes and what these errors mean and stuff. But yeah, okay, cool. We do get them. However, there's some reason this doesn't. If error not equal to 0, so if 0 is like no error, okay, then we'll do it. Let's see if solution rebuild solution. Okay, so we still get the code, which is good. Now let's just change this back to unsigned short, run the code. Hopefully now we should not get the error, and we don't, which is great. Okay, cool. That's good. Yeah, so our error handling system also works. That's good. That's pretty much it. That's what I actually planned to do. That's pretty much everything I planned. I had written like a small note in my copy. I know the things that I wanted to do, and I finished it. Okay. Since this is a chill stream, I'll probably show you guys how I at 4 looks good. Yep, everything here looks good. Okay, so since this is a chill stream, I'll probably show you guys how I push my code to GitHub. So let me open GitHub real quick. Here's my GitHub. If you guys don't know about GitHub, you can follow me on GitHub as well. By the way, I'll give this link in the description box below. This is the actual repository that we are working on. So illus2D engine is a public repository. I've made it public. You guys can look and see everything that we have. This is the thing that I want now. I'll probably just clone. Oops. I'll probably just like I'll show you how I send my data in. See 2D game engine, illus2D engine. I'll open the command prompt. Get status. So we modified a bunch of files. Git add. We want to add everything that we had modified. We'll do git commit with the message. So something like code maintenance. Is that spelling of maintenance? Maintenance. Okay. Oops. Oh, what the hell did I do? Oh. Maintenance. Git add everything. I'll do we have git commit dash. Oh, where's the music? Where did the music go? Did they stop the live stream? Hope they didn't. Nope, they didn't stop the live stream for some reason. The music is gone. Right, I'll just do something like git commit dm. I'll do code maintenance. Okay, so all committed. Get status. Oops, get status by one commit. So I'll do git push, and hopefully everything's gonna get pushed. See? Where's the music? Where's the music? Where's the music? Okay, everything got pushed. If I take a look at my GitHub page again, take a look at sandbox. There's the music. Okay, so yes, so go to source code maintenance, and we see that our commit. Yeah, see, 39 seconds ago. Our GitHub profile is done. It's updated. Okay, cool. It's awesome. So I'll leave the link in the description box below. I guess I can do it right now, right? Yeah, I'll just leave I'll leave my GitHub page here. I'll leave this GitHub page right around here. Okay, cool. Save. That's pretty much for this stream, guys. Next stream we're going to be getting into input handling and stuff. That's pretty much it. Just stay tuned for. You can see my OPS. Stay tuned for next episode. The next episode is going to be fun. Okay, just like every single episode. After input, we're probably going to be getting into like making an orthographic camera, and after we make the orthographic camera, we're going to be getting into a really fun stuff. Is writing a renderer. And writing a renderer is going to be really challenging. It's going to be really fun and educational. And after we write the renderer, we can do stuff like make awesome sprites and do awesome stuff. And we're also going to be getting into stuff like batch rendering, batching textures, drawing like 50,000 stuff on the screen, but with a single draw. Oh yeah, batch rendering is awesome, guys. Okay, cool. Just stay tuned for all these awesome episodes. Hopefully the next stream is probably going to be after 2 or 3 days because it's pretty hot outside. Like I said, I really need some break. Okay.